Imagine a factory receives an order to build 1,000 custom skateboards by next week. How do the managers know exactly how many individual nuts, bolts, and wheels to order today so they don't run out halfway through the job? They rely on a document called a Bill of Materials, or a BOM. You can think of the BOM as the master recipe that defines the structure of any manufactured product. The defining rule of this recipe is that it focuses on a single item. A bill of materials details the exact quantities of components required to build exactly one unit of the product, in this case, one single skateboard. It is also important to note what a BOM is not. It is strictly a list of materials. It tells you what goes into the product, but it doesn't describe the assembly steps or the machinery used. Those instructions are kept in a separate document called a routing file. By isolating the exact material needs for just one unit, factories create a structural map. This helps purchasing departments avoid ordering the wrong parts and keeps the assembly line moving during massive production runs. To see how this works, we can look at the finished skateboard as a collection of distinct interconnected components. This is a single-level bill of materials. It displays only the components that are directly attached to make the final board: one wooden deck, two metal trucks, 4 wheels, and 1 sheet of grip tape. But a single-level view only tells part of the story. If we look at this metal truck, it arrives as a finished part, but it is actually an assembly made of even smaller pieces. This is where a multi-level bill of materials comes in. It cascades downward into a family tree, showing how parts are logically grouped together. It breaks that truck down into a base plate, a hanger, a kingpin, and rubber bushings, reaching all the way down to the final purchased parts. There is a strict rule here. If a component changes physically, like painting a raw wooden deck, it becomes a different part with a different identity on the bill of materials. To keep everything organized, every single variation and subpart on this tree is assigned its own unique part number. This multi-level structure ensures that every hidden screw and internal bushing is accounted for on paper before the physical assembly ever starts. Let's take this digital structure out of the computer and onto the factory floor to see how these lists drive actual manual labor. When it is time to build, the data from the BOM is used to generate a checklist known as a pick list. This pick list serves as a formal authorization. It tells the warehouse staff exactly which parts they need to collect from those bins to prepare a specific order for the assembly team. By using the BOM, factories remove the guesswork. Workers have the right materials ready for their shift, which keeps the production line from coming to a halt. Now we can solve the problem of scaling up to 1,000 skateboards. We know the recipe for one board, but calculating the total parts for a massive order requires an automated approach. Factories use a software system called Material Requirements Planning, or MRP. This system uses the BOM to calculate exactly how many components the factory needs to buy or build. During a BOM explosion, the system multiplies the 1,000 board order by the BOM quantities. One board needs 4 wheels, yielding 4,000 wheels. Moving level by level, 1,000 boards require 2,000 trucks. Because each truck needs 2 bushings, the system outputs 4,000 bushings. This calculation is the engine that translates a single order for finished goods into hundreds of accurately timed purchasing orders for every individual component. This works well for standard items, but what about a factory where customers customize their boards with different wheel colors or deck styles? If every order is different, you can't use a standard bill of materials to know what to buy in advance. You don't know which parts a customer will choose until they actually place the order. To solve this, manufacturers use a planning BOM. This is a special grouping of items used to simplify the process of planning out the factory's long-term production calendar. The planning BOM uses historical trends to estimate demand, instead of representing a specific product. Past sales might show a 60% probability for red wheels and 40% for blue. This statistical estimate ensures factories prepare the correct inventory ratio before customers click buy. Whether it's calculating the parts for a massive production run, guiding warehouse workers to the right bins, or estimating the materials needed for future sales, the bill of materials provides the structural framework for the entire manufacturing process.